Welcome back, everybody, for another deep dive. This time, we're going to tackle a question that's been around for
Oh,
centuries.
yeah?
Is mathematics
Yep.
just a tool that we humans invented, or is it the actual language of the universe?
Whoa.
We've got some excerpts here that explore this idea of a profound connection between math and, the fabric of reality.
Right.
So let's dive in and see what we can unpack here.
Yeah, what's captivating about this whole topic is that it really goes beyond just simple numbers
Yeah.
and equations. It's really delving into the very essence of reality itself.
Oh, wow.
We're exploring whether mathematics just describes the universe
Mm.
or if it's somehow, like, woven into its very being.
So it's like asking, is math something we discovered,
Right.
or did we create it?
Exactly.
Yeah.
Yeah. And our source material here, it dives right into this debate.
Okay.
Starting with the concept that mathematics isn't just about calculation.
Yeah.
But it's about recognizing patterns and relationships and structures
Mm-hmm.
that exist all around us.
I like that.
And this idea, it's been around for centuries. Think back to Pythagoras and his famous all is number philosophy.
Yeah.
It's fascinating how this ancient concept still resonates with
Yeah.
modern mathematicians and physicists today.
So how does this ancient idea connect to all the cutting edge science that we have today?
Well, let's consider the strange world of quantum mechanics.
Okay.
In the quantum realm, things get very weird,
Oh, yeah.
and our everyday intuition completely breaks down.
So we were talking about like particles being in multiple states at once.
Yes.
Cats being both dead and alive, that kind of thing.
Exactly. Phenomena like superposition and entanglement, these have been experimentally confirmed.
Wow.
Yet they challenge our fundamental understanding of how reality should work.
Oh.
What's incredible
Yeah.
is that the behavior of these particles, however bizarre it may seem,
Yeah.
is predicted and explained by complex mathematical equations.
Really?
It almost suggests that the universe, at its most fundamental level, operates on principles
Mm-hmm.
that are deeply mathematical.
So the math isn't just describing this quantum weirdness, it's actually predicting it.
Precisely. The math was there before we even observed these phenomena.
Oh, wow.
It's as if the universe is speaking to us in a mathematical language, and we're just slowly learning to understand its vocabulary.
This unreasonable effectiveness of mathematics, as some people call it, is a pretty profound concept.
I think so.
But why is it considered unreasonable?
Because it's not obvious why math, something we humans developed,
Yeah.
should so perfectly describe the universe. Take the discovery of Neptune, for example.
Okay.
Astronomers noticed some irregularities in Uranus's orbit,
Mm-hmm.
and using Newtonian mechanics, they predicted the existence and location of another planet,
Wow.
Neptune, which was later observed exactly where the math predicted it would be.
So math isn't just describing what we already know, it's predicting things we haven't even seen yet.
Exactly, and it goes beyond our solar system.
Okay.
Einstein's theory of general relativity, this predicted the existence of gravitational waves, ripples in the fabric of space-time,
Right.
long before we had the technology to detect them. And guess what? Decades later,
What?
we finally observed those gravitational waves,
Really?
confirming Einstein's predictions with
Oh.
incredible accuracy.
Okay, I'm starting to understand the unreasonable effectiveness here.
Yeah.
But how does general relativity, which deals with gravity and space-time,
Right.
connect to this weirdness of the quantum world? It seems like those are two completely different realms.
Yeah, it's a great question.
Yeah.
And it highlights one of the biggest mysteries in modern physics.
Okay.
We have these two incredibly successful theories, quantum mechanics for the very small
Mm.
and general relativity for the very large.
Yeah.
But they don't quite fit together.
So there's like a missing piece of the puzzle.
It seems that way.
Mm.
Physicists are actively searching for a unified theory
Oh, wow.
that can explain both the quantum world and the cosmos.
Yeah.
And many believe that mathematics holds the key.
So maybe understanding the language of mathematics is the bridge to unlocking the secrets of the universe.
That's a very real possibility.
Wow.
The more we delve into the language of math,
Mm-hmm.
the more we realize its power to describe and even predict
Yeah.
the behavior of the universe,
Mm.
from the tiniest particles to the largest structures.
But if math is this universal language, shouldn't we see it reflected here on Earth too?
Absolutely.
Not just in the stars and galaxies.
And we do. Nature is brimming with mathematical patterns.
Yeah.
revealing this deeper order beneath the surface of things.
Right.
Take the Fibonacci sequence, for example,
Okay.
where each number is the sum of the two preceding ones.
Right.
It appears in the spirals of seashells, the arrangement of leaves on a stem, the branching of trees,
Wow.
countless other examples.
And then there's that other famous example, the golden ratio,
Yeah.
which seems to pop up everywhere.
It does.
In art, architecture, even the human body.
Yes, the golden ratio, approximately 1.61H. It's a fascinating example. It appears in the proportions of the human face, the spiral patterns of sunflowers, and even the structure of galaxies.
Really?
Some believe it represents this fundamental principle of aesthetics and design, a kind of mathematical harmony woven into the fabric of the universe.
It's really making me rethink my relationship with math. I always saw it as this subject in school,
Yeah.
not a fundamental language of reality.
Right.
But if it's this deeply embedded in nature, it makes you wonder, is math something we invented? Or did we stumble upon this language that already existed?
That's the heart of the debate, isn't it?
Yeah.
Could math be a human construct?
Okay.
A tool we developed to make sense of the world?
Yeah.
Or is it a fundamental truth, a code that underlies reality itself?
So are we talking about invention or discovery?
Right.
If we hadn't invented math, would it still be out there woven into the fabric of the universe?
That's a question that philosophers and mathematicians have been grappling with for centuries. Consider this mathematical principles like pi
Okay.
or the Pythagorean theorem.
Right.
They seem to exist independently of human perception.
That's true.
It's not like we decided pi would equal approximately 3.14159.
To just IS, and we figured out a way to describe it.
Exactly. And let's not forget about the fundamental forces of physics.
Okay.
Gravity, electromagnetism, the strong and weak nuclear forces. They all follow precise mathematical relationships,
Right.
regardless of our understanding of them.
So the math was there governing these forces long before we even knew they existed.
Yeah.
That's a lot to consider.
It is.
On the one hand, we have these symbols and equations that we invented, but on the other hand, these underlying mathematical concepts seem to exist whether we're aware of them or not.
Right.
It's really making me question this whole nature of invention versus discovery.
It's a fascinating conundrum.
Yeah, it is.
If mathematical truths are inherent to the universe, it raises this tantalizing question. Would intelligent life elsewhere in the universe have developed the same mathematics as us?
That's a really mind-boggling thought.
It is.
If they did, wouldn't that further support the idea of math as this universal language?
Right.
But if they didn't, wouldn't that suggest math is, at least in part, a human construct?
It really makes you ponder the nature of reality, doesn't it?
It does.
Some physicists, like Max Tegmark,
Okay.
believe the universe itself is a mathematical structure.
A mathematical universe hypothesis.
Yes.
So is he saying everything in the universe, from galaxies to grains of sand, is essentially a mathematical equation?
In essence, yes.
Wow.
Tegmark argues that everything we perceive as physical reality is ultimately a manifestation of mathematical structures.
Okay.
It's a radical idea
It is.
that suggests our universe is indistinguishable from a complex mathematical model.
Wow, that's a big leap. What do other scientists say about this hypothesis?
It's certainly a controversial idea.
Yeah.
While some physicists find it compelling, others argue that mathematics is simply a powerful tool
Okay.
that we've developed to describe and understand the universe,
Yeah.
not the universe itself.
Right.
It sparks a debate that goes beyond physics,
Okay.
delving into philosophy and metaphysics.
So it's a question of whether the universe is fundamentally mathematical or
Right.
whether math is simply the best language we've found to describe it.
Exactly.
Okay.
It's a debate that may never be definitively settled,
Right.
but it certainly fuels some fascinating discussions.
It does.
But regardless of where you stand on the mathematical universe hypothesis, there's no denying the profound role
Yeah.
mathematics plays in our understanding of the cosmos.
Speaking of understanding the cosmos,
Yes.
our deep dive today has taken us from the mind-bending world of quantum mechanics
Yes.
to the vastness of the universe,
Right.
governed by mathematical laws.
Mhm.
And we've seen how those same mathematical principles, like the
Right.
Fibonacci sequence and the golden ratio,
Yeah.
are reflected here on Earth in the patterns of nature.
Exactly.
It's a lot to absorb.
It is.
What has stood out to you from all of this?
What's truly captivating is the sheer elegance
Yeah.
and interconnectedness of it all.
Okay.
From the smallest particles to the largest cosmic structures.
Right.
There seems to be this underlying mathematical order,
Okay.
a language that speaks to a deeper reality.
Yeah.
And the fact that we as humans can decipher even a fraction of this language is both humbling and awe-inspiring.
It's like the universe is whispering its secrets to us through these patterns and equations.
It is.
Maybe all we have to do is learn to listen more closely.
Perhaps those deeper mathematical secrets
Yeah.
hold the key to unlocking a profound understanding of existence itself. Imagine gaining insights into consciousness, the origin of the universe,
Yeah.
or even the nature of time.
Right. These are some pretty heady implications, wouldn't you say?
Absolutely.
Yeah.
Before we go too far down that rabbit hole,
Okay.
let's take a moment to recap what we've explored so far.
Okay.
We started with the idea that mathematics might be more than just a human tool,
Right.
that it could be the fundamental language of the universe itself.
Exactly.
We then jumped into the strange world of quantum mechanics,
Yeah.
where mathematical equations describe a reality
Right.
that defies our everyday intuition.
Mm-hmm.
And from there, we zoomed out to the vastness of the cosmos,
Yes.
governed by mathematical laws that predict the movements of planets,
Right.
stars, and even entire galaxies.
That's amazing.
We also explored how those same mathematical principles,
Right.
like the Fibonacci sequence and the golden ratio,
That's-
are mirrored here on Earth in the intricate patterns of nature.
Exactly.
And we grappled with the age-old question
Yeah.
of whether math is a human invention or a discovery,
Mm-hmm.
a tool or a blueprint,
Right.
and we pondered the mind-blowing implications
Right.
of what it would mean if the universe truly is a mathematical structure,
Yes.
as Max Tegmark proposes.
Mm-hmm.
It's a lot to take in,
It is.
but it's incredibly stimulating.
I agree.
It makes you realize how much we still don't know about the universe
Yeah.
and our place within it.
That's true.
It's a journey of exploration, isn't it?
It really is.
And the more we explore,
Yeah.
the more we uncover these amazing connections
Yeah.
that make the universe such a fascinating and mysterious place.
I agree.
Whether math turns out to be an invention, a discovery,
Right.
a tool, or even a blueprint,
Mm-hmm.
one thing is clear.
What's that?
It's the most powerful bridge we have
Yeah.
to understanding the universe.
And who knows what incredible discoveries await us
Right.
as we continue to explore the language of mathematics.
It makes you wonder, like, what amazing breakthroughs
I know, right?
might be just around the corner.
Yeah.
Maybe we'll unlock the secrets of dark matter,
Yeah.
dark energy.
Or discover new dimensions we never even knew existed.
Imagine harnessing the power of quantum entanglement
Whoa.
for like instantaneous communication across vast distances.
Yeah.
Or using these advanced mathematical models to predict and mitigate the effects of climate change.
That would be amazing.
The possibilities are truly staggering.
It's both humbling and exhilarating to think about.
It really is.
It reminds us that even with all of our scientific advancements,
Yeah,
we're still just scratching the surface of what's out there.
absolutely. And it really underscores the importance of curiosity, exploration, the pursuit of knowledge.
Mm-hmm.
Who knows what incredible insights
Right.
we might uncover as we continue to delve deeper into this language of mathematics.
As we wrap up our deep dive, I want to leave our listeners with one final thought to ponder.
Okay.
If the universe truly is a mathematical structure, as some physicists suggest,
Yeah.
what does that imply about the nature of reality itself?
Whoa.
Are we living in a giant simulation? Is free will an illusion?
These are profound questions
They are.
that have puzzled philosophers and scientists for centuries.
Yeah.
And while we may never have definitive answers,
Right.
the very act of asking these questions, I think, expands our understanding of ourselves
Yeah.
and the universe we inhabit.
I completely agree.
Yeah.
We hope this deep dive has sparked your curiosity and inspired you to see the world through a slightly different lens. Perhaps the next time you encounter a mathematical concept,
Yeah.
you'll view it not just as a tool,
Right.
but as a glimpse into the underlying structure of reality.
Until next time,
Yes.
keep exploring, keep questioning,
Yeah.
and keep seeking out those awe-inspiring connections
Well,
that
it's
make
smart.
the universe such a fascinating place.